Let us discuss the continuity or discontinuity of the function fx equal to mod of x minus 2 divided by 2 minus x for x not equal to 2 and minus 1 for x equal to 2 at the point x equal to 2. So we draw x-axis and y-axis. What we want to do is we want to draw the graph of this function. When x equal to minus 2 minus 2 gives us minus 4 and minus of minus 4 is plus 4. So mod of x minus 2 is equal to plus 4. How about the denominator? Minus of minus 2 is plus 2 and 2 plus 2 is 4 and 4 by 4 is 1. So for x equal to minus 2, fx equal to 1. For x equal to minus 1, we got minus 3 and then minus of minus 3 is plus 3 and denominator is also plus 3, again 1. For x equal to 0, again we get fx equal to 1. For x equal to 0, fx is simply equal to 1. For x equal to 1, 1 minus 2 is minus 1, mod of minus 1 is plus 1. Oh, yes, 2 minus 1 is 1, so 1 by 1 is again 1. However, the function is simply equal to minus 1 for x equal to 2. We mark the coordinates x equal to 1, 2, 3, 4, 5, 6, of course at equal interval, then minus 1, minus 2, minus 3. And then y equal to 1, 2, of course we will be plotting fx instead of y, minus 1, minus 2 and so on. Okay, when we take x equal to minus 2, we got fx exactly equal to 1. Let's plot it. When x equal to minus 2, fx is simply equal to 1. When x equal to minus 1, fx is simply equal to 1. When x equal to 0, fx is again 1. When x equal to 1, fx is again equal to 1. Okay, let's draw that. You see that it's simply a straight line that passes through these points. How about if x equal to 1.5? You see that 1.5 minus 2 is minus 0.5 and mod of minus 0.5 is again plus 0.5. 2 minus 1.5 is again 0.5 and 0.5 and 0.5 will get cancelled, so you will get 1. As long as I do not take x equal to 2 and as long as I take x less than 2, I find that fx is exactly equal to 1. So we just draw a gap here. So that's the graph of the function fx equal to mod of x minus 2 divided by 2 minus x for x not equal to 2 and x less than 2. How about when x equal to 2? If x equal to 2, fx is exactly equal to minus 1. If x equal to 3, 3 minus 2 is 1, mod of 1 is 1, 2 minus 3 is minus 1 and 1 by minus 1 is again minus 1. For x equal to 4, 4 minus 2 is 2 and 2 minus 4 is minus 2, 2 by minus 2 is again minus 1 and so on. So for x equal to 2 minus 1, for x equal to 3 minus 1, 4 minus 1, 5 minus 1, 6 minus 1. So we join those points and again we get a straight line. An obvious question is, can I move continuously along fx? Yes, I can move continuously, but when I reach near to and as I cross to, I have to take a jump. I have to take a jump. So the function is discontinuous at x equal to 2. Now that's not enough. That's we can say it by looking at the graph that function is discontinuous at x equal to 2. Now we need to prove that the function is discontinuous at x equal to 2. We will do the same by computing right hand limit of fx at x equal to 2 and then left hand limit of fx at x equal to 2. Let's start by the right hand limit of fx at x equal to 2. Right hand limit of fx at x equal to 2, that means we will be taking x greater than 2, is nothing but limit x tends to 2 plus, that means we are taking x greater than 2 of fx. Let's write x equal to 2 plus h, so that's simply equal to limit h tends to 0 plus of fx, but as x is greater than 2, fx must be equal to whatever be it, even if it is greater than or less than 2, fx is simply equal to mod of x minus 2 divided by 2 minus x. But we are writing x equal to 2 plus h, so let's replace x by 2 plus h. So this limit is equal to limit h tends to 0 plus 2 plus h minus 2 is simply h divided by 2 minus, instead of x I write 2 plus h. So that's equal to limit h tends to 0 plus mod h divided by minus h. Remember, h has to be greater than 0. As long as h is greater than 0, mod of h is exactly equal to h, and so this ratio is just equal to minus 1. Okay, let's look at it, the graph. If I take x greater than 2, fx is always equal to minus 1. So as I approach from the right hand side, I get the value of fx exactly equal to minus 1, and I approach to minus 1. That's fine. From the right hand side, I approach to minus 1. How about from the left hand side? Once again, we try to determine the limit x tends to, in this case, 2 minus of fx. That's equal to limit h tends to 0 minus, we are simply writing 2 plus h equal to x. So if x tends to 2, h must tend to 0. So we will be replacing x by 2 plus h. The rest of the expression we can copy as it is. Replace x by 2 plus h. Remember, h has to be less than 0 because we want x less than 2. We want the left hand limit, or we want to get nearer to 2. We want to get nearer to 2 from the left hand side. 2 and 2 gets cancelled. 2 and 2 gets cancelled. So this limit is simply equal to limit h tends to 0, again minus of mod of h by minus h. Remember, if h is less than 0, if h is negative, then mod of h is simply equal to minus h. So this is limit h tends to 0 minus h divided by minus h, and that turns out to be 1. If we look at the graph, as I move nearer to minus 2, as I move x nearer to 2, I tend to get fx nearer to plus 1. Yes. Are left hand limit and right hand limit equal? No. Since left hand limit and right hand limit are not equal, we can say that function is discontinuous at x equal to 2. So, f is discontinuous. There is a break. By discontinuity, we mean there is some kind of break. F is discontinuous at x equal to 2. We can see it from graph, and we did prove it as well.